This chapter will discuss observational methods. And so we can kind of break observational methods down into two basic types. Direct observation occurs while observing behavior, involves observing behavior while it actually occurs. So you're observing the behavior live, either with or without intervention. So the intervention refers to researchers' efforts to change or create kind of a context for observation. So if you're observing without intervention, it's naturalistic observation. And if you're observing with intervention, there may be several different types of research or intervention you might see. And then the other general type of observational method is indirect observations, where we observe past behavior. So sometimes these are called unobtrusive or non-reactive observations. The behavior has already happened. We are looking back at either past records, either archival records, archives of behavior that indicate behavior, or physical traces that show evidence. When we're recording behavior, we have to consider a couple of things, but one is kind of how we're going to record it. So do we take a comprehensive record of every single thing that's going on? So for example, a narrative record is a reproduction of behavior as it actually occurred. So getting some kind of in writing every little thing that happened. Or maybe an audio or video recording or field notes. And what you do is you just record every single thing that happens, and then later on, you kind of classify things and go back and look. These are kind of ideal because we can always go back and kind of look at things that we think we might have missed or check for things. You know, maybe we're observing bullying on the playground and we take recordings of this, but we become interested in the victim's response, which was not something we had initially planned to study. Alternatively, we might select specific behaviors. So we might have a clear idea of the behaviors that we are interested in. And so we might kind of clearly, explicitly define them and only record those behaviors. So for example, if I'm observing children's behaviors at recess, maybe I select a specific set of social behaviors that I'm interested in, and I just identify whether they're present or absent, or maybe rate how frequently or how extreme the behaviors are. And this is important because the method you choose determines how your results can be measured and summarized and analyzed. If you use some kind of comprehensive record like a video or audio, as I mentioned, you can go back. If you only select specific behaviors, your options are a little more limited. Another really important aspect of the types of data you collect has to do with the measurement scale. And so how we quantify specific behavior determines what kind of analyses we can do. So if we're using a nominal scale, we've got some sort of discrete category. So, you know, what color shirt were they wearing or something like that. If you're using an ordinal scale, you're rank ordering things on a single dimension. So of the 3 kids you observed, which one was the highest on aggression, then the next highest, and the third highest. If you're using interval scale, you might specify a distance between stimuli on a given dimension. So rate the kid's aggression from 1 to 5. Okay. And then a ratio scale would be specifying the distance that has a specific set of ratio values. So this might be something like count how many times a kid punches another kid. Okay, with a ratio, you have a true 0, a meaningful 0. So it's often counting or measuring things. And so which type of data you collect, again, determines which type of analyses you can do. And there's 2 general types of analysis. Qualitative analysis is about describing behavior, typically with words and not statistics, and kind of developing a theory in a more organic way that explains observed behavior. So when you're doing qualitative analysis, your data reduction is going to involve summarizing records through kind of maybe narrative kind of records. You might do some coding of, you know, saying, hey, I'm interested in these specific behaviors, so I'm going to go back and look for them. things like that. You might also do a content analysis of archival records, kind of see what kind of information you can glean from them. Anytime you really are counting behaviors, you're moving into quantitative observations or quantitative analysis. And this is kind of more what we'll focus on. So quantitative analyses are more numerical summaries of observations. And so these involve more descriptive statistics. So they describe data, and the possibilities really depend on which level of measurement you use. Okay, so if you're using nominal measurement, which a lot of observations that use kind of checklists for certain behaviors use nominal, you can talk about the relative frequency. So you might say 75% of people in the cafeteria were eating alone, 25% of them were eating with someone else. If you used ordinal, you can talk about items that are frequently ranked first. So something like 54% of people ranked Lowe's as their favorite hardware store. When you use interval or ratio measures, it gives you a lot more information. You have a lot more options. So you can look at the mean. So you can look at the typical score. You can look at the standard deviation, which is the average distance from a mean. So for example, if we're looking at IQ scores, the average IQ is 100, but the standard deviation is 15, which means the average score, the central score is 100, but most people stand within 15 points above or beyond. The vast majority of people are within 15 points of 100. If it's a big standard deviation, it shows there's more variability. And so having this quantitative data gives us an additional way to look at information. Another important component of observation is inter-observer reliability. So reliability has to do with consistency of our measures. And when we're talking about inter-observer reliability, we're talking about, do independent observers viewing the same event obtain the same results? So if two different people who watch the same behavior don't agree, we don't know what actually occurred because the behaviors weren't clearly defined. So it's important that if you have independent observers, they're actually independent. So they need to not be aware of what the other person records. And you want to kind of select a certain percentage of observations to check for reliability. So for example, I did a large observational study and we aimed to do reliability checks on 20% of those observations. When you're using nominal data, especially with mutually exclusive categories, meaning you have to pick which one behavior people did, you typically look at percentage of agreement scales and you aim for 85%. So if we watch 20 behaviors and agree on 18 of them, then we got 18 out of 20, which equals 0.9 times 100 means that we agreed 90% of the time. For ratio and interval observations, we do a Pearson correlation. So we'll talk about correlations again when we talk about survey research, but correlations are also important for assessing reliability. So I've got a couple of links on Moodle to help you better understand correlations, but generally a correlation is a relationship or an association and a measure of the direction and strength between two variables. When we talk about reliability in correlations, we're talking about the relationship between two observers' scores. So the direction is when one increases, does the other increase or decrease? If we're talking about inter-observer reliability, then one would hope if one observer ranked a child as more aggressive, so would the other one. And then the strength is how fast does the other increase or decrease. So you can get a correlation coefficient, which is a statistical measure of association. And so, for example, you know, something like how long your feet are and the size of your shoes are going to have probably a close to perfect correlation. So a positive one or a negative one are considered perfect correlations, pretty rare in social sciences. A correlation or no correlation would be a 0. So for example, height and IQ scores are not going to be related at all or very small, so they would probably be close to 0. So the range of a correlation can be anywhere from -1 to +1. Almost all relationships that psychologists and social scientists study are less than 1. So to give you an example of what this looks like, we can imagine that, for example, our X is an SAT score and Y is college GPA. So we might be asking the question something like, does knowing an SAT score let you predict GPA or vice versa? So I think that often it's easy to envision correlations by using these kinds of scatter plots. And so, for example, in this one, this would be a perfect positive correlation, a correlation of 1. If we know the SAT score, we can exactly predict GPA, and people who get lower SAT scores always get lower GPAs. People who get higher SAT scores always get higher GPAs. The second one is a pretty strong positive correlation, but it's certainly not perfect. Okay, so it may be 0.7 or something like this. This is more what we'd expect. We'd consider a really high relationship, but not perfect. But this will be really good for social science research. So in general, people with lower SAT scores have lower GPAs, and people with higher SAT scores have higher GPAs. So each dot represents a person here. But there are exceptions. So for example, this person right here, this dot right here indicates a person who has a pretty low SAT score, but a relatively decent GPA. Or in contrast, this person right here has a really high SAT score, but his GPA is just kind of middle of the road. And so the fact that there are exceptions are the things that makes it not a perfect correlation. This is what it would look like if there were no relationship or no correlation. This would be a 0 correlation coefficient. This will be a perfect negative correlation. So this might be something like the number of classes you've missed and your score on the test. The people who have missed, no, so this is a perfect negative correlation, so -1. So for this, if you miss no classes, you got a perfect score on the test. And if you miss every class, you got a terrible score on the test. Probably not quite so close. So it might look something like this, which would be a negative correlation. Again, I'd say that's probably maybe 0.7 or something like that, where in general, those who missed fewer classes scored higher on the test, and those who missed more classes scored lower on the test. So this is the negative. The variables go in different directions. High on one means low on the other. But there are exceptions, right? This person up here missed a lot of classes, but actually did okay on the test. And like this person right here missed a couple, but not a ton of classes, but did terribly on the test. And so these exceptions are what make it not a perfect score. So like I said, we will talk more about correlations in the coming chapters, but this is kind of a basic preview of observational research in general, and then correlations, which we use in observations to assess the inter-rater reliability.